Okay, so last video we talked about the summation notation, and now we're going to actually put that into practice. When we talked about this earlier, I told you guys that we would be working more with finite sequences, so not the infinite where they are running, from a certain value of 1 to n. We are going to be running them between specific values. So, like this says up here, the index does not necessarily have to start at 1 and end at n. There are different values that they can start and end at. So, for this case here, we will be starting at 5, okay? And then we will be ending at 8. Now, the formula that I'm going to be using is 2k plus 1. Okay, so I'm going to start with that formula here, and I am going to start with 2k, but my first value for k that I start with would be a 5. So instead of having a k there, I'm plugging in a 5 because that is my start value. So I have 2 times 5 plus 1. Okay, the next one that I'm going to work with is, again, 2 times k plus 1, but the next term after 5 would be 6. Then I will move on. Again, 2 times 1, or 2 times k plus 1. Next term, I go 5, 6, then 7. Okay. The last one I do would be 2 times 8 plus 1. Now, how did I know that was my last one? Well, because it says that this should end at 8. Okay. What do I have in between each of those? Well, the sequences, we would put commas in between each of these, but remember, we are no longer dealing with sequences, we are dealing with summations. Okay, so that means that in between each of these, I should have a plus sign. Now from here, you're just going to simplify. 2 times 5 is 10, plus 1 is 11, plus 2 times 6 is 12, plus 1 is 13, plus 2 times 7 is 14 plus 1, which is 15, and 2 times 8 is 16 plus 1, which is 17. Okay, now your answer for this, I'm going to have you guys stop right here. I'm not actually going to have you guys add these up all together. So you would say that your summation is 11 plus 13 plus 15 plus 17. The reason that I don't have you add them up together is because your college algebra professor does not want you to add them up. This is how he has them leave their answers on their test. So I'm just trying to keep in line with what he does. You could add them up together. If you added them up together, that'd be 24 and 32, and 24 and 32 would be 6 and 56. So technically this summation equals 56. Okay? But for what we're doing, I want you guys just to leave them in their summation form with the plus signs in between there. And again, it's not that you can't add them up, it's just that this is how you will do it in college algebra, and I want you guys used to doing that when you head into it. Okay, let's do another one together. Okay, now this one might be considered a little bit trickier. Not by our start and our end, those are both fairly similar, but this has 2 different values of I. So I'm going to be plugging in my start value twice on this one. So first, I have a -1 to the I power. So I'm going to start with 2 because that's my start value, -1 squared. And then in parentheses, I'm going to have another 2. Okay? So my first one that I'm adding up together is -1 squared times 2. Because there were 2 different spots I had to plug in my I. Okay, then since it's a summation, I'm going to have a plus sign there. Okay, next I'm doing the exact same thing, -1, but now I'm going to have a 3, because that's the next number in the summation. I go again and I will have a 4, now in both of these spots here. Okay, and then my last one that I have will have a 5. Okay, now when I go about simplifying this thing, you guys are going to find a pattern on this. Everywhere that there is an even exponent, it is going to eliminate that negative sign with that -1. So -1 squared, well, that's just -1 times -1, which is a +1. Okay, so we end up with +1 times 2, plus, when I have an odd exponent, however, -1 times -1 times -1, well, these two negatives give me a +1, and then that +1 times a negative gives me back to a -1. So your even exponents will get rid of the negative, but your odd exponents will end up just keeping the negative there. Okay, so I have a -1 times 3 there, plus even exponent, so that's going to get rid of that 1, so it's just a 1 times a 4. Odd exponent, the negative is going to stay there, so that will be a -1 times a 5. Okay? Now, to simplify this thing here, 1 times 2 is 2, minus 3, plus 4, minus 5. Now, I have had people in the past that have said, well, is this really a summation because there are subtraction signs there? The answer is still yes, because subtraction is just adding a negative. But if you wanted to, you could write this as 2 plus -3 plus 4 plus -5. That would also be a correct answer as well. Okay, but those are the two most common summation types that you guys will see as far as having your index value being up in an exponent, and then also just one where you're simply just adding and a number in and then just multiplying and adding them. So we have two more. On these last two, I would really appreciate it if you guys would pause and try these two on your own. Okay, and then I will explain how to do them afterwards. Okay, so hopefully you guys have paused the video. This one is just 3k minus 2, so starting out with, my start value on this would be a 2. Okay, so I have 3 times 2 minus 2, plus, next value would be 3 times 3 minus 2. And then finally, again, I know this is the end value because it's the top one up there. I would go 3 times 4 minus 2. Okay, so 3 times 2 is 6 minus 2. 3 times 3 is 9 minus 2. 3 times 4 is 12 minus 2. So I end up with 4 plus 9 minus 2 is 7 plus 12 minus 2 is 10. Okay, again, you can add those up together, but I'm going to ask you guys just to leave them as your summation pairs there. Another way that I have seen kids show their work on these, and I'll just do it on this next one, you're going to start with 3, so it's -1 to the 3rd power times 2 times your 3. Okay, so I'm just plugging them in. Some of the kids will write them vertically like this, and then they'll go -1 to the 4th power, and then 2 times 4. And then we would go -1 to the 5th, 2 times 5, and -1 to the 6th, 2 times 6, and we would end there at your 6 because that is your top value, which means that is your end value. So some kids will write them vertically like this. So this is going to be a -1 cubed, odd, keep the exponent, 2 times 3 is 6, so that is -6. Even exponents get rid of the negative, and that is 1 times 8, so that's a +8. Odd exponent, keep the negative, so that gives me -10. Whoops, that looks like a 16. Sorry about that. That gives me a -10. And then again, last one, even, so it gets rid of it. Gives me +12. It works to show your work like this. Just make sure that for your final answer, you write them out in a number sentence. So -6 plus 8 minus 10 plus 12. And that would be your final answer for that one there. So when you guys get back to class, we will just practice again with these summations. And this is all leading us towards the binomial theorem, which is a summation that is used a lot in statistics. And we will be using it to expand binomials like 2x plus 3 to the fifth power.